How's it guys? Welcome back to the Apex training videos. Today we're going to be talking about racking. So where is the racking located? So your racking either screws onto or into your steering rack. From there it connects to the outer tie rod ends, which then connect to the steering knuckle, and it translates the rotational movement of your steering wheel into linear movement, moving your road wheel in and out so you can turn. What are the main components of a rack? I'll cut this one apart so I can show you. You have your ball, which is hardened steel. Then you have your racket shaft, which is threaded to accept your tie rod end. Then you have your ball socket, which would sit like that, encapsulating the ball. And on that, you will have the ball liner. On your ball socket, you'll either have a pin with a male thread to screw into the steering rack, or you will have a female thread to screw onto the steering rack. It just depends on the vehicle. The last main component of a racking is the lock washer. So once you have tightened the racking onto the steering rack, this lock washer is then bent and it locks your racking in place. The racking is a crucial part of the steering system because besides the movement that it allows, it's also imperative in setting your motor vehicle's wheel alignment. So how it works is basically like this. As you turn your steering wheel, it is a rotational movement. The steering wheel, because it's a racket pinion, it's an angled gear, converts that into linear motion to your left and to your right. So your rack, besides moving from left to right to allow you to turn the vehicle, it also needs to be able to move up and down as your steering moves up and down while you're driving on the road. A very important point about a racking is how rackings are made and the difference between good rackings and bad rackings. So a racking has to have what we call preload on it. This ball liner and its ball socket need to be crimped in such a way that this pin and ball can rotate and move freely, not have any end play on it, and it mustn't be too stiff. If you've got too much play on your ball liner, what's going to happen is when you turn your steering wheel, you're going to have free play on your steering wheel. So in other words, as you turn your wheel a little bit, your wheels will stay stationary, but your steering wheel will turn. Then what's going to happen is this ball liner is going to wear more rapidly. And as it wears more rapidly, that play will increase. And eventually, you will start hearing a clucking noise. The other problem you're going to have with that, the more end play you have in the socket, the harder it will become to set your wheel alignment until it gets to a point that you cannot set your wheel alignment. So the wheel alignment setting that's critical because of the racket is going to be your toe in and toe out. So if our hands were your wheels, your toe in and your toe out is that movement. When you're driving a vehicle and you accelerate, your wheels have a tendency to want to pull out like that. But when you set up your wheel alignment, it keeps your wheels straight. Now, if you have too much play in this ball socket, what's going to happen is you won't be able to get enough adjustments to keep your wheel straight. And if it's on the one side, your one wheel will either pull in or out, and that's going to lead to increased wear on your tires and more rapid wear on your tires. Of course, cost you to have your tires replaced on a more regular basis. The other thing that's going to happen is because of this, as you're driving along on the road, your car's either going to drift or it's going to pull to the side, especially under braking. That's a safety critical issue. You don't really want excessive play on these rackets. Now, quite often guys will buy a racket and they'll try and move it, and if it moves freely, they're going to say, no, there's play on the racket. Play on the racket is when you actually have movement in this ball socket. If you could take this racket and move this shaft up and down, that is play. That's if you now set the preload on the ball socket too loose. The problem is if you set it too tight, and that's where the guys really get confused and they think, oh well, the tighter the better. The problem is if you've set this too tight, the first thing that's going to happen is this ball liner is going to wear more rapidly. The other thing is your steering is going to be exceptionally stiff and it's not going to be nice and free when you're driving. The problem with that is when you drive your car and you turn your steering wheel, if you let go of your steering wheel, it will return almost to the straight ahead position, making it easier for you to get your car straight. If this ball socket preload is too tight, your vehicle is not going to return on its own. So then you're going to have to bring the steering wheel back, making it a bit more dangerous to drive the vehicle. So now you're going to have rapid play, you're going to have a very stiff steering, but those are problems that can be overcome. What people don't realize though, if this preload is too high, this motion when you turn in your steering wheel, or say your suspension is moved up or moved down, it's going to put linear forces on this racket because now it's not moving the way it should. What's going to happen with that is it's going to put, if you've got a vehicle with manual steering, it's going to put excessive pressure on the bushes on either side of your steering rack. So what will end up happening is your steering rack bushes will wear out quicker. But it doesn't just stop with the bushes. You're now putting excessive wear and strain on the teeth of the steering rack and the teeth of the pinion. So your steering rack is going to wear out a lot quicker. You're going to get play in parts of your steering rack where it cannot be repaired. It needs to be replaced. If those teeth wear enough, or if this preload is tight enough, you could also end up chipping the teeth on your steering rack. So either way, you're going to end up damaging your steering rack and having to replace the steering rack. That's if this preload is set too tight. So now this preload, the term for it is articulation preload, and it's measured in Newton meters. The spacing between this ball liner, this socket, and this ball, that is all worked out by the people that design the racking. Into that equation, they add the thickness of the grease as well. And then they will determine how much force is needed when crimping this. When I talk about crimping, when they assemble the racking, this socket will be one, it won't be cut like it is here. And these sides will be straighter like that, allowing you to pop the ball pin liner into the socket and insert the ball at its shaft. Then it goes into a press. Just imagine my hand as the bottom die, my other hand as the top, and it will be pressed into the bottom die. It's a uniform die, which then crimps the socket around the shaft. That will then determine the preload on your racket. Once they've done this, they then need to test the preloads on your racket. So in mass production, they'll take 1 out of 50 or 1 out of 100, and they will do tests to determine if the preload is correct, and that batch can then go out. This is articulation movement. This movement over here. When they test it, it's articulation preload. There's two settings that they look for. So you will have your brake force, which will be the amount of force required to move it from its standing position. Then you're going to have your second reading, which measures how much force it takes to keep it in movement. The way these things are tested, your shaft would be put into a tool to hold it, and you would have an angular torque gauge on this end with an adapter holding it here. And as you move that angular torque wrench or torque gauge, you would check the readings as you go, and that will tell you what the preload is. The damages you can pick up if this preload is too high on a manual steering rack. And now if you go look at most vehicles today are power steering. As soon as this preload is too high, you put excessive strain on your steering rack, and that in turn causes the hydraulic fluid to heat up, because now you're putting strain on your power steering pump. So the fluid heats up and the pressure within the pump increases because it's now harder to turn the steering. Inevitably what happens is that will then cause the hydraulic seals in your power steering pump to fail. Your power steering pump will start leaking fluid. It also will lead to excessive heat, and that will lead to damage to the bearings within the pump, because now they're running at greater heat than what they were manufactured to. And your bearings start to run, and eventually your power steering pump fails. The other thing that can happen is on a power steering rack, you have high pressure seals on your left and your right of your rack where your shaft moves through, and on the top of your pinion where your pinion goes into the steering rack, you have these high pressure seals. And because of the added pressure brought on by this articulation preload being too high, you can pop those seals as well. So you can end up damaging your power steering pump, your power steering rack, and your tires. So by the time you finish, a part that should cost you 200-300 has now cost you 6,000-7,000 Rand for a steering rack and 12,000 Rand for a power steering pump. That's the inconvenience of now having those parts. Either you have to wait for them to get new ones, or you've got to wait for them to be repaired. And in some cases, they can't repair them at all. You have to throw them away and buy new ones. But technology has improved and things have changed, and you don't just have hydraulic power steering anymore. You now have electrical power steering as well, or power assist steering. So that all works with an electric motor. What happens there, as soon as this articulation preload is too high and it puts excessive strain on your electric power steering rack, your electrical motor now needs to draw more current to operate to give you that smoother steering. So if you leave the problem, what's going to happen? Again, bushes will wear and you have the possible damage to the teeth, but now you have possible damage to your electric motor. So what's going to happen is first your vehicle's ECU, electronic control unit, will throw out fault warnings and fault codes. And then after a while, the vehicle will just go into limp mode and the steering will get heavy and you won't be able to drive it as you want to. Then you're going to have to go in and have everything reset. It's not something you're going to be able to check at home. So what we're going to do now is we're going to go to how do you measure a racket. So there's three critical measurements on a racking. The one is the length, the other one is the thread pitch, and the diameter of the thread. So if we take this racking, some manufacturers measure the full length of the racking, from the beginning of the thread to the end of the thread where it screws onto the steering rack. They would measure it like that, and that would be a 295mm long racking. At Apex and other manufacturers, we measure from the end of the thread on the racking shaft to the end of the flange on the ball pin socket. So that would make this 281 mils. That measurement is critical because if you get a racking that's too long, they have toe out, and if you get a racking that's too short, they have toe in. The next critical measurement is the thread. The first thing we got to do is measure the thread diameter. So that's a 14mm thread diameter. So you've got to say, oh, but that's only 13.8. All these things have tolerances built into them for machining and because they're mass produced. So that would be a 14, and the pin on the socket would also be an M14. So now we need to determine the thread pitch. If you look at that thread, there's lines at the top of the thread. So your thread pitch is measured from the one line to the other line. And what that actually is the distance between the two top points on your thread. And it's got to be the same for all of them. So what I'm going to do now is I'm going to show you how we actually measure this. There's your thread pitch gauge. As you can see, the sizing is on there. So if you take this bottom one, that's 0.8 of a millimeter. So now I'm going to show you how it works. So if you put your thread pitch gauge on there, you shouldn't see any light to where it's raking over the threads. So now on this one you can. So that tells me, okay, this is obviously not a 1mm thread pitch. I'm going to say if it's not a millimeter, then it must be a 1.5. So now, if you put that on properly, you can see no light coming through there. That tells you that it's meeting or meshing very nicely with the thread pitches. So the pitch and the valley. That tells you that is the correct thread pitch. So these measurements are in the catalog. So when you go and buy a rack end, it's always good for them to check those measurements. Rack end itself on South African road conditions will last anywhere between 80,000 kilometers and 150,000, 160,000 kilometers. If this is not holding your steering straight while you're driving and it suddenly comes loose or breaks, your one wheel will either go in or out on the side that it's broken. And if you're traveling at the right speed, you're either going to skid into the pavement or you can end up rolling your vehicle. So racking is actually a safety critical item. It's all got to do with how the safety critical component is manufactured. So if you're taking your vehicle in, please ask them to check the steering rack boots to make sure they're not torn. If you start hearing a clucking noise, your vehicle pulls or wonders when you're on the road, go have your rackets checked out. If that boot tears, it's not just damage to this ball socket. That dust also gets in on your steering shaft and aids in wearing down your steering shaft bushes a lot quicker, and on power steerings that eventually end up damaging the seals. So I hope this bit of information I've given you guys has helped and will help you in the future. And I'm going to ask you to please keep watching our socials. We're going to be posting more little training videos for you guys. Thanks a lot, guys. Cheers.